Stats review part 2. In this video, we're going to talk about probability distributions. First of all, binomial distribution. Now remember, binomial, bi, stands for 2, so this one we have 2 options. So it's either going to be success or failure. So 2 options. In your formula sheet, it looks like this, right? Here's the binomial distribution little packet, right? So most of the time this is on the calculator, but if you want to get it by hand, it's going to be right here. The mean's this, right? Expected value mean, so they can ask for either one. That's the formula. And the variance, they give you a variance also. And again, if you want to find standard deviation, you just square root it because the variance is bigger. Binomial is one where probability of success is your p here. So we're going to do this. Probability of success is p. This is one where I also gave you r is what you want, the number want, and n is the total number of trials. Now we do 2 sets of binomial problems. There's binomial PDF, the normal probability distribution, and that's you just do x equals r, or whatever value you want. X equals 3, 2. They want it, so this one they'll say exactly, generally. And there's binomial CDF. So CDF is a cumulative frequency one. And the key about that is you want x is less than or equal to a. That's what you want. That's the whole goal. So if you don't have it, if you have greater than, let's start with the easy one, less than, which looks like x is less than a, or x is less than 3 or something like that. You got to go down. You got to get the equal to sign, so you got to lower a level. And then you plug that in. X is less than or equal to a, right? The whole goal is get the less than sign. Now let's how about if it's greater than? If they say greater than x, a, so x is like that. Notice that's pointing in the wrong direction. Anytime it's pointing in the wrong direction, that's the one you got to flip it. So it's going to be 1 minus x. Now, keep in mind this is an open circle, and the complement of that would be a closed circle, less than or equal to a. Right? Greater than, you had no open circle. I had to flip it to point in the wrong direction. The only time you do the 1 minus if it's pointing in the wrong direction. 1 minus binomial CDF of x minus a. And then we have, what if it's just greater than? Then you have the x is greater than or equal to. I should say we just did greater than. Another way to say this is at least. It's a big word to say, right? So the fancy word they'll say is at least. So I always think about like at food. If I want at least 3 cookies, then lowest I could go is 3. So greater than or equal to 3. That's at least 3, right? Again, notice it's pointing in the wrong direction. So I gotta do 1 minus again. So do 1 minus x's. Now, if you flip this, now again, you had the closed circle already. The opposite would be an open circle. So just the less than. I guess in this case, it should have been an a. Right, now again, notice it's like over here. I have no equal to sign, so I gotta go down a level. So that's the most annoying one, is where it says at least, because you got to flip it and you also got to go down a level. But that's the general idea. If it's a binomial CDF, you need less than or equal to sign. If it's PDF, you just put x equals. So let's do a couple examples. So this one, Ian often has coffee in class. Often has a coffee in class. Each day there's a 91% chance, that's my probability, that he'll bring coffee. What is the probability he will have coffee at least 3 classes this week? So we need a couple of things. So let me show you first. Right, if we bring in our calculator, turn it on as always. We go to distributions because we're doing binomial distribution. So second distribution. There's no one we're gonna use that. We're gonna use you later. We go down toward the bottom. There's binomial PDF and CDF. In this case, we're doing PDF exactly 3. So PDF. So it has trials, P and X value. That's our NPR basically. Our P is easy to tell us 91%, so change that to decimal, 0.91. R, I want exactly 3, R is 3. Now what's the number here? Now it says classes this week, so we generally go to school 5 days a week. So N is 5. So that's all the information I need. So I go back to my calculator, I'm going to put 5 trials, 91 is my probability, and X value is 3. Hit paste. And I get about 0.061. So I'll put binomial PDF to show work. x equals 3. Probably show that also, and I get probability equals 0.061 if I remember correctly. And we're done. What is the probability that he will have coffee at most 2 classes per week? So again, at most, that means no more than, so less than equal to 2. Now notice how it already has the equal less than sign. We're good. Again, also it's less. Okay, so it's less than, so I don't gotta flip it, and it has an equal to sign. So I'm all set. This is gonna be a binomial CDF. X is less than or equal to 3. Everything else is the same. Still n. It's still probability. Our r changed to 2 now. So again, at most we're doing a CDF. We're doing cumulative frequency. So I'm gonna go back to my distribution. Go down to binomial CDF. Everything else is gonna be the same. So it's gonna be 5 trials, 0.91%, and now only 2. At most 2. So I get 0.006. Again, what that's doing is, if you want to know what that's doing, 2 classes. It's adding the probability of getting 0 coffee plus probability of getting 1 coffee plus probability of getting coffee twice a week. That's what cumulative frequency is. You're adding 0 plus 1 plus 2. 0 days a week, 1 day a week plus 2 days a week. All encompassed by this binomial CDF. I get that answer. What's the probability he'll have coffee for at least 3 classes a week? So at least 3 is this one. At least 3. Notice it's pointing in the wrong direction, so I gotta do 1 minus x. It has an equal to sign, so I gotta lose it. And I'm like, oh, I gotta go down 1 because I don't have the equal to sign. So 1 minus x is less than equal to 2 because they go down a level. So that's what I'm gonna put in my calculator. 1 minus binomial CDF of x is less than equal to 2. So my calculator, I'm gonna go 1 minus. Now look, we already did it. I'm just gonna click up there. Did that earlier. 0.994. You can also, if you notice, these are opposites of each, or complements of each other, so you can just do it that way. 1 minus that answer. But that's a basic binomial question. Let's do a couple more. Brett plays a game 6 times. Already got my n. The probability of winning exactly 4 games is 0.24, with the probability of winning a single game. So I know the probability binomial PDF of x equals 4 is 0.24. But I actually don't have what p is. So I'm missing something. So I'm going to do this. I'm going to use a formula. So if we get my formula sheet, right here is the thing. The probability equals n over r, p 1 minus, let's write down that formula. So probability you want, the answer equals n over r, p 1 minus p to the r, and minus r. I believe is what the formula is written. And we're going to kind of put stuff in we know. Okay, I know this is 6, because that's my n. I know my r is 4. I want exactly 4. Probability, I don't know. N minus r is going to be 2. 1 minus probability is 4. All this equals, I know what the answer is, 0.24. So how do I solve this? This ugly mess? Your calculator. y1, y2. Let's graph this thing. Right? That's all you have to do. It's a binomial problem, because you're going to have exactly, you could win or lose a game. And they give you all this information. So I'm going to go to y equals, type it all in, 0.24, 6C4 right there. So I just put 6C4 if I want. 6 math, probability, NCR 4, 4. Then we're going to times that by x squared. Now again, I don't have a p, so let's put x squared. And then we're going to times that by, I need parentheses for this one because it's 1 minus x. The whole thing to the 4th power, so caret 4. Hit graph. Now I'm not going to see it because my window's off from last time. Let's go to zoom standard. So I get that, and I get that. And if I notice, I still can't see anything. So you have 2 options. You could go zoom fit, or you could try to use some logic and go, wait. My other one's 0.24. So let's change my window. Okay, so here's our window, right? Let's talk about what's going on here. We're looking for P, which is my X. That's probability. Remember, probability could only go between 0 and 1, right? Lowest probability is 0. Max probability is 1. So that's done. My Y min. Well, I want to see where it crosses at 0.24. So my Y max could be anything around there. You can put 0.24 if you want, but you want to give it a little leeway. So I'm gonna go 0.5. Also could have just done 1. Hit graph, and then I see where it crosses. All right, and the way we find the intersection, we go to second calculator, find intersect, get close to 1, hit enter a couple of times, and I get 0.494. By the way, how do you show some work? You just graph it. So you're graphing it, looks like this, and like that, and that's 0.494, I believe it was. So that's one answer. About a 50% chance. And then we do the same with the other side. Second calculator, intersect, move on closer to the second one, hit enter a couple of times, and you get 1.195. So that's where the other one's at. Those are my two answers for P. About 20% chance and about 50% chance of winning a single game. So that's binomial distribution. Let's move on to the granddaddy, normal distribution. IB loves normal distribution. You can see one of these in every single test. And honestly, you probably see binomial problem in every single test, but normal they love. So a normal distribution, remember, just the normal, everything in left kind of follows the normal distribution, right? Most people in the middle, then as you get to the endpoints, it gets less and less. You can think about it in height, most people around there, then there's a median height for most people. And then there's a few people that get super tall, and a few people are super small. Now these percentages you generally don't have to memorize straight out, but in the middle right here, between 1 standard deviation of each side, is 68%. And then as you go a little further out, it's like 95%. And as you get further out, most people fall between 99.7% of this data right there. That's a normal curve, right? Most things follow a normal curve. Right here is the median. And it should also be the mean. What do you expect to happen? What you expect to happen in the middle to happen. So the normal curve, the median, and the mean are the same thing. Now, then we start talking about z-scores. And you're like, what are z-scores? That's just how we normalize things, right? The height for men and women is different. So how do you tell if someone's taller for their gender? We normalize it. And that's what this formula here is for. It's called the normalization formula. And you have it in your formula sheet. Right there. So when you need it, you need to find z-scores. And z-scores is normalization. It makes the mean and median of 0. It makes each standard deviation 1. And that makes a lot of things really easy to see. Because now if you have a negative z-score, you know you're below the standard deviation. If you get a positive, you're above the standard deviation. So if you want to normalize something, use that formula. Now when we talk about normal, there's generally 3 types of problems. One way to say find probability. Someone say something like find probability that you're greater than, I don't know, 20, right? And then you plug in, we'll talk about it in a second, but you plug in your calculator. It helps if you shade it, and you find it. The next one's I give you a percentage, and you have to find the value. I'll say like 20% of people are below X. So you got to find what X is, since you know it's 20%. And the last one is if you're missing. You have to find the mean or standard deviation or both. So if one of those is missing, you gotta normalize. We'll do one of each so you can see it, but that's the general idea. Now, first things people ask is like, how do you know it's a normal problem? Well, normal is the easiest one to tell because they're gonna tell you it's a normal problem. We'll give you some examples right here. Every single one of them will say it's a normal distribution. It's a normal distribution. One thing you gotta watch out for is if they say standard normal, if you see the word standard normal, that means they want you to use 0, 1. So your mean's gonna be 0, and your standard deviation is gonna be 1. So that's the only thing you gotta watch out for. Most of the time they give it to you, but if they happen to say the keyword standard normal, they're talking about the z thing here, and that means your mean is 0 and your standard deviation is 1. So keep that in mind. So let's do an example. To the left, determine the area to the left of z-score 1.3. So already, I'm thinking, okay, the z-score is standard normal. That is that. This is 1. I like to draw these things so I have an idea what I'm talking about. So if I draw my normal curve, not a very good one. Right, the middle is 0 because it's standard normal. And I'm at like 1.23, so I'm over here somewhere. And I want left of it, so I want all of this. So how do we do this? On our calculator, we're going to go to distributions, back there. Actually, let me go back to the home screen. There you go. Let's go to distributions. Now we're going to do normal. Now we're only going to use two things in this class. We use normal CDF and invert normal. That is it. Cumulative frequency normal and invert normal. Now the reason we use normal CDF because we're trying to add up all this area here. We're going to do the cumulative area of this right there. So normal CDF is the only thing we ever use. And going back to here, type 1 is a normal CDF problem. That's a type 1, that's the easiest version. And then give a percentage is invert normal. We're going to go backwards. I'm going to do that in a second. Find the mean or standard deviation is a z problem. We got to normalize. And we'll do that in a bit. So that's the 3 different type of problems of normal. So this one we're doing normal CDF. Now if we look at our calculator, it gives us this lower, upper, mean and standard deviation. So in this case, my lower here is my lowest, and that's negative infinity. If you remember, our calculator cannot do negative infinity, so what we're going to do is negative E99. And that's a chemistry, and we'll talk about it in a second. Now, it's my lower bound. My upper bound is the highest I go. In this case, 123. 1.23, sorry. That's my upper bound. So my calculator here, my lower bound, say they already have it set up for you, negative 1 E99. We could, if I was doing this myself, whoa, didn't mean for that to happen. If I was doing that myself, I was put negative E. Now it's this E right here. It's called a chemistry. Don't use that fancy. It's a different thing. That's Euler's number. We're doing this E. So second E, 99. Upper is 1.23. Now this is very important. Since we're doing the z-score, like I said, our mean estimation is 0 and 1. So I don't change anything. And I get 0.891. So again, we always do 3 sig figs. That's the area or the probability of getting less than 1.23. Again, that was a standard normal. Let's do a non-standard normal. Next problem. The heights of high school basketball players are normally distributed with a mean of 177, so that's my mean, and a standard deviation of 4. So that's this. And I don't have an A problem. I believe the A problem was A was something to the effect of what probability of boys or basketball players, girls also, what probability of basketball players is greater than, let's go 190 centimeters. Right, so now I want to know how many players, what's the probability of getting something that's greater than 190 centimeters. So again, I like to draw it. Now I know my mean's 177. I don't worry about standard deviation. I want to go 190. Well, 190 is on this side somewhere. And I want greater than, so I want this. So same idea as before. How am I going to do this? Well, lower bound is 190. Upper bound is over here, which is infinity, also known as E99. Everything else I have. So your calculator is going to go second distribution, normal CDF. My lower bound is 190. My upper bound is E99, so second E99. It's positive, so I don't worry about the negative. My mean I got to change. It's 177. And my standard deviation, I covered it, is 4. Hit enter. And that's a really small number. Remember, that's significant. That's scientific notation, that's basically 0.000571. In this case, 3 suffix point. No, that actually. So we have that. Really small number. So that's A. Let's look at B. What's the probability that randomly selected high school basketball players between 169 and 185? These are actually the easiest ones. Cause here's 177. So 169, 185. So 169 is over here somewhere. 185 is over here somewhere. And you want in between. Why I think these are the easiest ones? Because you already have your lower bound and your upper bound. No need for E99. Go back to your calculator, second distribution. So I'm going to go 169 to 185. Everything else is the same, still the same mean, still the same standard deviation. Hit enter. And about 0.954. About 95% chance of getting someone that's in between those two heights if you pick randomly. Next one. In a group of 25 high school basketball players, how many do you expect to be 182 or shorter? So this is a little bit twist to that. So they want me to find 182 or shorter. So same idea. Here's 177. 182 is over here somewhere. And I want shorter. So I'm going to go negative E99 to 182. Let's go. It's just easier to do distribution. So negative. Notice I did that for negative E99. I didn't put the subtraction sign because I'm not a monster. Then 182. Everything else stays the same. And I get 0.894. Now normally you're done because it says what's the probability. But not in this case. It says in a group of 250 high school boys, how many you expect to be that one? So I'm going to multiply that, my probability, by n, expected value. Right? Probability times the number of things you have. So let's multiply by 250. And I get about 223.5. So about 224. Students, players, whatever. So that's the idea. That's way 1. Now let's talk about inverse normal, way 2. The students of class X sat at a physics test. The class average score was 46, standard for a physics class, and the standard deviation was 25. The teacher decided to award A to the top 7% of the students in the class, assuming that the score is normally distributed. Again, notice how they tell you. Find the lowest score that would receive an A. So let's draw this. This is 46. And it says the top 7. So keep in mind, right? This side's bottom half, lower, shorter. You draw on the top half if it's top or greater than. So tallest, whatever, like if it's something that loses the low end, draw from the left side. Something that refers to the high end, draw from the right side. So this right here is 0.07. And watch that out. A lot of people get lazy and just put 0.7, right? 7% is 0.07. Now in this case, notice I have a percentage. Dead giveaway for inverse normal. You have a percentage, you can do inverse normal. Now it looks like this. Let me show you on the calculator. So if we're doing inverse normal, second distribution. Notice it says area, mean, and standard deviation. We have the mean and standard deviation already. I don't have the area. That means the percentage. So this is the area underneath the curve. Now here's the one gist if you're doing. Here's the one snafu if you're doing inverse normal. Has to be on the left side. Has to go from here. So if you're doing inverse normal, the area has to be from the left side. So over here I got 0.7 on the right hand side. Well, good lucky for us, this whole thing is 1. So that makes this left hand side 1 minus 0.07 or 0.93. So that's the area I put in there. I already have the mean standard deviation. It's 46 and 25. It's a low test score. So I'm going to put 0.93. 46 is the mean and 25 is standard deviation. That's also a very big standard deviation, by the way. So it sounds like a crappy class. Hit enter and you get about 82.89. So 82.89 or 82.9. It's the least you need to get. 83. I'm guessing. Well, who knows the class? You need a score of 82.9 to get an A. It's the lowest value you could get for an A. And that's the way inverse normal works, right? So again, there's 3 ways to do it. If I just say what's the percentage, just straight out normal normal CDF. If I give you a percentage, you can do invert normal. So another one real quick. The scores on aptitude tests are normally with a mean of 80 and a standard deviation of 11. Probably the student score is lower than 88. So right, I'll just draw it. I'm gonna save you some time. Here's 80, score less than 88. Normal CDF, negative E99 to 80, and then put the mean and standard deviation. Blah, blah, blah. This percentage of students score between 65 and 85. Well, I'm gonna draw it again because I like to draw it. 65, 85. Again, in between, right? I don't have a percentage, so normal CDF, 65 to 85, mean and standard deviation. Greater than 65. Draw it. Here's 65. I'm on greater than. So normal CDF. Lower bound 65. Upper bound infinity, we don't have that, so E99. Mean and standard deviation. Then the next one. What mark did 90% of students score above? So it's a little tricky. So what mark did they score above? So I'm starting on this side again. But 90% of the students, well, right, this whole thing's 100%, so 90% is like over here. All of this is what we're looking for. What score did 90% score above? So again, notice how I give you the percentage. So you know it should be invert normal because I give you a percentage. Same mean standard deviation. Now my area here, again, has to be the left-hand side. Well, this is 0.9, so this must be 0.1. Plug this all in, you get an answer. Next type of problem, though. Here we go to the big one, the last type. Right, so we did invert normal, which is the second type of problem, which they give a percentage, and we did normal CDF is when they just ask you what's the probability between this and that. The last frontier is if something's missing, if a mean or standard deviation missing, or both are missing. In this case, like I wrote up there, notice how it says in this case, well, let's read the problem first. This isn't an athlete jumps for no reason. Again, notice I tell you, with the mean of that, if 50% of the jumps by athlete are less than 5 centimeters, what is the standard deviation? So I'm missing standard deviation. So anytime you're missing one of these, you have to use the z function. So just from our formula sheet, this is x minus mu over standard deviation. You have to use this. So just like I wrote up here, right? If you're missing one of these, you have to use this formula. I wrote it terribly right there, though. That's an awful rendition of it. So this is the formula, straight from the formula sheet, right there. So how does this work? Well, step 1 is write that formula down. So if you're missing something, write this formula. Again, it's only if it's normal. It's in the normal part. 2, we got to find z. You're like, how do I find the z here? Well, z is always the same way. That's good news. It's invert normal where my standard deviation and mean are 0 and 1. Because remember, z stands for standard normal. So we're doing the invert of that, and it's 0, 1 always. And 3, plug z and other values, other given values in to find what you want, to find the variable. So that's the steps. It's 3 steps, right? First, we write down the formula. Good, we check, got that. Next, we got to find z. So let's look at what we have here, right? We have our mean. And we have this thing. If 50% of the jumps this athlete are less than 5 meters with standard deviation, this is important. What does that say? That says the probability that the person to jump less than 5 meters is 15%. Hugely important. Why is that so big? Because, like I said, our z is invert normal. That's what we got to find next. Of the area, which we'll talk about in a second, and 0, 1, standard deviation mean. Because again, z is always 0, 1. You should never have a z that's not 0, 1. Now what goes here? Well, this thing does. But we got to talk about what it means. just like up here, right? Anytime I give a percentage, that's the area, and we have to be on the left-hand side. So in this case, if I draw it, I don't know where 5 is. Oh, the mean's 5.5, so it's a little before that. The percent, I want less than that. So that part is 0.15. We lucked out. That's the area we want, right? We always want the left-hand side. So this is 0.15. So we're going to put this in our calculator. We'll go to distribution again. So second vars, invert normal. Now my area is 0.15. I already had up there. Now again, we're going to do 0, 1. We're doing z, so it's automatically 0, 1. Hit paste. So negative 0.04. So now I can plug this in. That's my z. Fill the rest of it out. X is this. This is x, 5. So that's my x. And I have my mean 5.2. So I just have negative 1.04 equals 5 minus 5.2 all over standard deviation. Do a little math. Negative 1.04 equals negative 0.2 over standard deviation. Multiply both sides by that. Divide by this. And if I do that, I should get, so negative 0.2 divided by, I'm just going to divide by the answer. Anytime you have a chance to, divide by the actual answer instead of your rounding value. And I get 1.193. So my standard deviation goes 0.193. Remember 3 sig figs. So that's the idea. If you're missing things, we follow these steps. Anytime you're missing one, follow these steps. Okay, last one. In this case, let's go full on. We're missing both things. Find the mean and standard deviation. You don't have either. Right? So find the mean and standard deviation of a normal distribution. Again, they always tell you if it's normal. And they give you these two. So step 1, let's write the equation we need. So I need that. Again, in this case, I'm missing both of these. So I need, next I gotta find z. So we're gonna do one for each. We'll do one for this one. So the way this works is, remember that's telling me that. I'll write the equation. This says, if I draw it so I could see what's going on, less than 20 is 0.1. So this is 0.1. So remember, we gotta find z. So z is just invert normal, 0.1, because we're on the proper side. Mean and standard deviation is always 0, 1, guys. So remember, I don't have it here, but when you're doing z, it's 0, 1. So we're going to put this in our calculator. So invert normal, 0.1, 0.1, enter, 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 negative 1.28. So that's my z. So my equation here, I have negative 1.28, it's my z, equals, well, x in this case was 20. So 20 minus mu over standard deviation. So that's as far as I could go. Actually, I can make it a little pretty. I'll multiply both sides by standard deviation. Standard deviation, 20 minus x. Just so it's not as ugly. Now we gotta do the next one. We gotta do this one. Same idea, same formula. But in this case, they're telling me when I'm greater than 29, I'm at 0.15. So if I do this, greater than 29 is 0.15. So when I do my invert normal to find my z, remember I cannot use 0.15. I gotta use the left-hand side. So 1 minus that is 0.85. That's what I have to use. Has to be the left-hand side. So all that we just put in our calculator. 0.85. 1.04. If I round to nearest 3 sig figs. And again, by the way, just to keep in mind, this makes sense. This is a little 0.1. Notice how I draw it? It's on the left side, so it should be negative. I got a negative value. This one, I drew it on the right side, so it should be positive. I got a positive value. It should make sense. So let's plug into the formula. 1.04 equals, again, x this case was 29. 29 minus mu over standard deviation. Again, just like before, make it a little prettier, multiply both sides by the standard deviation. 1.04 equals 29 minus mu. So we get to this point, you're like, okay, how do I solve this? I have two variables and two equations. And this is where I get mad at you and say, remember algebra 2. Two unknowns, two equations. You could do elimination or substitution, right? Either way works. So that's all I have to do here is elimination, substitution. I'm always been a fan of elimination. You can do either one. I'm going to do, I think, elimination here also. So I'm going to have negative 1.28 theta equals 20 minus mu. I'll rewrite this one here also. 1.04 theta equals 29 minus mu. If I want to try to get rid of the mu's, I'll multiply one of these by negative 1. So I get 1.28 theta equals negative 20 plus mu. These cancel. I get 9 equals, let's see, I could do this. 232 mu divided by 2.32. And you get the standard deviation is 9 divided by 2.32. 3.88. 3 sig figs. Right, and then once you got one, just go back, plug into any one you want. That's the closest, that's the clearest one to see. Do some math, you're gonna get mu equals 29 minus that monstrosity. Let's put in my calculator real quick so I could see it. 29 minus 1.04 times 3.88. And I get 24.25 essentially. And that's the idea. So keep in mind, there's only 3 types of normal problems, right? The normal one, where I just say, what's the probability? You just do normal CDF, lower bound, upper bound. If I give you percentage inverse normal, if you're missing one, you got to use the z value. And then find z, plug it in, do some math. And that's it.